Kepler's laws. For discussion of Kepler's laws, in figure 1.2 an ellipse is given. Every ellipse has two focal points. In that figure, F1 and F2 are focal points. Points A, B, C are 3 points on the ellipse. Now, in each ellipse, the sum of the distances of the two focal points from every point on the curve is constant. It means that in this figure, AF1 plus AF2 equals to BF1 plus BF2 equals to CF1 plus CF2. This property about distance and points on the ellipse is found in each case. Now, by using this figure, 3 laws are described by Kepler. Now, what is the first law of Kepler? According to first law of Kepler, the orbit of a planet is an ellipse with the sun at one of the foci. According to second law of Kepler, the line joining the planet and the sun sweeps equal areas in equal intervals of time. And according to third law of Kepler, the square of its period of revolution around the sun is directly proportional to the cube of the mean distance of a planet from the sun. In figure 1.4, these 3 laws are discussed very well. In that figure, according to first law, the elliptical orbit of a planet revolving around the sun is shown. In that figure, S stands for sun and A, B, C, D are the points for planets. According to second law of Kepler, AB and CD are distances covered by the planet in equal time. That is, after equal intervals of time, the positions of the planet starting from A and C are shown by B and D respectively. The straight lines AS and CS sweep equal area in equal interval of time. Now, actually in figure, area ASB and area CSD are equal 1. According to third law of Kepler, if R is the average distance of the planet from the sun and T is its period of revolution, then T square is directly proportional to R3. That is, T square is directly proportional to R3. It means that T square upon R3, T square upon R3 is constant, which is equals to K. Kepler obtained these laws simply from the study of the positions of planets obtained by regular observation. But Kepler is unable to give more explanation why planets obey these laws. Kepler is unable to give more explanation why planets obey these three laws. For that purpose, Newton's universal law of gravitation is useful one. All considerations by Kepler now studied by Newton to formulate theory of universal gravity. According to theory of universal gravity, every object in the universe attracts every other object with a definite force. Repeat again. According to the theory of universal gravity, every object in the universe attracts every other object with a definite force. This force is directly proportional to the product of the masses of the two objects, and it is inversely proportional to the square of the distances between them. Now, consider figure 1.5. In that figure, M1 and M2 are two objects with masses M1 and M2. These two objects are kept at a distance d from each other. Mathematically, the gravitational force of attraction between these two bodies can be written as F is directly proportional to M1 M2 upon d square. That is, F equals to G M1 M2 upon d square. Now, here G is the constant of proportionality and it is called the universal gravitational constant. Here, if M1 and M2, which are masses of two objects kept at a distance of d, in this case, if M1 is doubled or M2 is doubled, at that time force becomes double. If D is doubled, at that time force becomes 1 upon 4th of original force. It means that if distance is doubled, the force decreases by a factor of 4, and if mass is increased, the force becomes double 1. This G, which is capital G, it is important to know that capital G is for universal constant of gravity. This value of G first experimentally measured by Henry Cavendish in SI units. The value of G is